is not the title of this. So, in doing this presentation, I actually went through a lot of iterations of what to call this, and this kind of what we settled on, mocking strategies. But since we're all in the span of like, mocking jokes and all that stuff, does anyone have any better titles for this? Like, just shout them out if you got one. Anyone? You guys obviously have not had enough beer to drink. All right, cool. So, this is what we have. Please don't mock me. Who am I? Can you guys in the back hear me? Like,
yep.
Yes, definitely.
So I have a projecty voice, so hopefully it gets back there. My name is Dan Davis. You probably already knew that. I've been a software developer for about 8 years. It's kind of interesting because I've been programming since I was 17, but my professional career started after I got out of college, so I count it as 8 years. Fun fact, I ran the Jingle All the Way 5K dressed as a giant gingerbread man. If you guys weren't there, this is what that looked like. If I may make some recommendations on things not to wear when running in a race, felt is really not breathable. So like, I was this big sweaty mess like when I got out of the thing, but people wanted to take pictures. I felt like a celebrity, so it was awesome. And people were like, "You can't catch me!" I'm like, this is a good time. Okay, but more seriously though, who am I? I actually came from the Java world, so like I was a Java programmer for about 5 years or so. Oh, and lost the connection. Fantastic. Oh, there it is. I came from the Java world, and that was kind of my thing. I have been a Python developer for about 2 years now, so I kind of made the switch. And I've also been doing a lot of DevOps work recently, which is kind of neat and interesting. So I've been spending a lot of time with quality and automation and trying to figure out like how do we get stuff up onto servers and like why do my developers just keep breaking the builds. So I care very much about software quality. Yeah, I'm very passionate about this. But it's not something that I think is like something you just kind of develop overnight. It's something you have to sort of get into. It's like a journey you have to go through. share a little about that. I became a certified Scrum developer about 2 years ago, maybe like 2 or 3, can't quite remember. That for me was a really, really awesome turning point in my career because somebody finally sat down and was like, okay, this is what software craftsmanship is. It's an amazing course that you guys can go through. It's amazing. Someone actually sat down and told me, this is what it is to be a good craftsman. This is how you write unit tests in a way that makes sense, in a way that's easy and actually supports building good software. The problem was I kind of learned this all in Java, and then when I switched to Python, it was a little jarring because I kept wondering, well, how do I do this stuff in Python? Like, I want to do all the things. Java's very structured and rigorous. Python is very like dynamic and open and does, it's different. So I kept dealing with these things like, you have this incredibly complicated framework like Django and their documentation's like, yeah, it's cool, you just write these tests, but they spin up this, test server and that makes sense, right? Because it's, it's not good. So I asked my colleagues about this. I said, what do you guys think? How do you do this stuff? And they actually said, we don't know either. They were honest. And when I asked a lot of people in the community, they don't know. And that's kind of sad. Unit testing is something we all should know. And so I wanted to learn, and more importantly, I wanted to talk to you guys about that. And I wanted to share that knowledge because I really, really believe this is important, and it's something that every developer here should know. We all want to be good developers, build quality code. So let's talk about unit tests. Everyone cool with that? All right. So you may have seen this pyramid. It's Martin Fowler's like unit testing pyramid, and he kind of his testing pyramid. And he's trying to explain like, well, how much of our tests should be unit tests and how much of our tests should be like integration or UI or browser or manual tests, right? And the vast majority is obviously unit tests. This poses a big problem for us. Many of us don't really know how to write good unit tests. So it creates a problem for us. If 70% of our stuff is supposed to be unit tests, then we've got a lot of learning to do. I hear a lot of things when I ask people about this. They have all kinds of bits and things like that they tell me. They say, Dan, here's the thing, unit tests are great, except when it gets complicated. And I tend to write a lot of complicated code, so I can't write unit tests, and that's really hard. Or like, they'll say, well, I have to write this really complicated unit test, but then I write a unit test for my unit test because the test is so complicated, and then it's just, I call this the rabbit hole of testing. That's not a good thing. Like, nobody wants to be in the rabbit hole of testing. We want simple tests. We want things that are straightforward. I also hear they tell me like, well, I find myself spinning my wheels trying to figure out how to test something. I write a lot of code and then I have to spend all this time looking up how to write the test. And that makes me feel unproductive, and I don't like that. What we really desperately all want is to be able to write effective tests. Be able to sit down like, yep, this is how I'm going to test it, this is how I'm going to do it. Done. Move on to the next thing. We don't want to spend a lot of time spinning our wheels. Last, sometimes people tell me that there's just stuff you can't unit test. They say, Dan, there's just stuff you can't unit test. And, I mean, in reality, I kind of agree to an extent, but I think that we overestimate like how, what that section is. It's actually a very, very narrow set of things that we cannot unit test. So, you know, there are times and applications for that, but the vast majority of the things that we can do, we can indeed unit test. So, the good news for everyone here is that mocking makes writing unit tests a lot easier, and that's a huge relief. It really is kind of like a night and day sort of difference. It is really a black magic of sorts. So, I hope you're all excited, because I am really super excited to be talking about this, sharing this with the community. Woohoo! Yay! See, that's enthusiasm right there. Yes, into that. Give that man another beer. Okay. So you might wonder, like, what are mocks, and how does that stuff work? So let's go back into computer science school. Let's remember how this worked. You may or may not have ever seen this. We have these things called test doubles, and they are like testing structures that allow us to test things. You have things like dummy objects and fake objects, where you're essentially just saying, here's a method, and I'm just going to call that, and it's, you know, just the different method that does stuff. But more interestingly, we have these things called test stubs, test spies, and mock objects. Now, what mock objects are, what all these things are, I refer to them in the common vernacular as a mock. But to people like in an academic setting, or maybe like, you know, in a white paper or something like that, this distinction is a little more important. Quite frankly, I think that's like esoteric and silly. Let's just call them all mocks for now. So for the purposes of this presentation, those three things are mocks, but know that there is a slight difference between these things. So for example, stubs are really used for providing canned response to a method, so I want to call it and it's going to do something that I want instead. Spies are real objects that behave and act like a real object, except when you tell them not to. Instead of being like a spy, right? Mocks are used, mock objects are used to verify behavior. So I call it and I say, were you called? It tells me yes it was, or no it was not. Does anybody feel like they got smarter in that? Like that was like a really good way to explain what mocks are good for, and like you guys, you can all go home right now if you think that was like what it was useful for. But for me, I think that it's not satisfying. The way that I generally approach these types of things is, what types of problems do mocks help us solve? Why are they useful? Why are they important? What do I want to do with them? So let's talk about that. I want to give you guys 3 problems that mocks solve. Okay? And if you guys remember anything, remember these 3 things. Number 1, mocks help us eliminate dependencies, right? So I have something that I want to test, and it's called something else, and I want to remove that dependency. So here's my method, everyone's favorite, foo. It's going to call this other method called bar in the implementation. And depending on what I get back from bar is going to affect how the rest of the method behaves. How can I possibly write a unit test for this? Well, you could like write a unit test for this thing, and if you understand like what bar does, then you could write a unit test for, you know, you could figure it out, but it wouldn't be pretty. So really, foo is sort of dependent upon bar. What we want to do is we want to eliminate that dependency. We want to make it so that we know for certain what the value of bar is going to be back. Simple enough, right? Okay. The second problem mocks help us solve. They help us solve methods that have no return value. Here's a method. It has no return value. But we would all agree that this has logic in it, and that logic needs to be tested, right? If x is greater than 10, it's going to call bar. How do I know a bar gets called? I don't know. Doesn't return anything. I can't write a test for this. It's impossible, you know? I mean, I guess you could write a test if you knew what the effect of bar was, and you could kind of like it's too much work. It's too hard. Mocks help us solve this problem. We can know if bar was called or not. Last one, error handling. This one is sort of overlooked a lot of times. And it's easy because sometimes we sort of like, well, I could sort of jury-rig this error to come up, and like a file, the IO error, like, oh, there's not a file there. Great, it's just missing. But what about errors that are really difficult to reproduce? So in this example, I have just some method, and it calls this thing called parse large file. And suppose, for whatever reason, maybe you were running out of memory on the server, you decided I want to put some code in there that will make it handle it a little more gracefully, right? Whatever you want to do, return empty string is probably not the best implementation. The intern probably wrote that. So how would we actually simulate this in a unit test? We can't. It's impossible, or it would be very, very difficult. How much RAM does the machine have? I could spin up a whole bunch of processes and try and crash the server, but I'm sure your ops people would not like that at all. They would be very upset. Mocks help us solve this problem. We can simulate error handling. We can simulate errors being thrown in an easy and understandable way. So great. Other things that mocks are really good for. They help us eliminate dependencies on databases. For example, let's say you were using a popular web framework, and that web framework insisted in their documentation that you spin up a test database every time you write a unit test. I don't know when that would ever happen, but if it does, we can actually eliminate that dependency, and it will speed this whole testing thing up. I don't have to spin that database up, and I don't have to rely on fixtures because they constantly break. We can reduce our testing complexity. This one is my favorite. I don't like writing really complicated tests because really complicated things are hard. Let's just write really, really simple, easy tests. And mocks help us do that. It makes it so that I can look at the test and it's just, there it is. Just specifically the thing I want to test and nothing more. Lastly, and this one is kind of neat and overlooked as well, if we have stuff that we're waiting on other people to write, especially if you're collaborating with another developer, we can actually develop simultaneously if we mock whatever it is that they're using. So I'm waiting for the intern to finish writing his method, and I want to get my testing done. I want to actually continue doing stuff. I can just mock that and write tests and whatnot, and it goes through. This can also save your butt in case you're doing like a demo, like a quick and dirty sort of like, and it's like, oh, it's not done, but I got 15 minutes. Toss in a mock, make it return to whatever value you want. Great, So it has a lot of other useful values. So you are all probably now super excited about mocks, right? I can tell. Yeah, see? Okay, great. Thank you. Thank you very much. So how do we actually do this? Good news, people who love Python, there are lots of options for you. Lots of options for you. And in researching this, it was like, wow. So just kind of going down the list here. So mock and magic mock is the one I'm going to base this presentation on. It's the one that I use. It's popular, it's robust, and you'll be excited to know that if you're using Python 3, I assume you all are using Python 3. If you're using Python 3, it is included in Builtin now, which is a huge endorsement for them. But let's say that's not your jam. You can also use FlexMock if you're coming from maybe the Ruby world and you're familiar with FlexMock and Ruby. You can use mocks. So if you're coming from the Java side and you're looking at like EasyMock and that sort of thing, you've got Mocker. Dingus is another popular one. Also, fabulous name. They're an interesting framework. You've got Fudge, also an interesting name, similar to like Mockito if you've ever used that in the Java world. And then Minimock if you guys are a big fan of DocTest. I put this list up here to point out that there are many, many ways to do mocks. Everyone sort of has their own favorites and their own thing. It's up to you guys. It's up to your own personal preferences. I'm going to stick with this one up here for this presentation, but I do believe that all of these do the things that we're talking about in some form or fashion. Read their documentation. Cool. Let's talk about sample problems. All right. So again, we have our 3 things that mocks help us solve. Let's just walk through those 3 things and do examples of each of them. But you know what, guys? Tell you what. I was inspired by the Track Maven like Valentine's Day stuff here. Let's make this a little. That's Saturday is Valentine's Day. Let's make this Valentine's Day. Okay. It's a little fun with this. A little sample problem. So I want to talk about finding true love on the internet. And by that, what I mean is Tinder. So let's say we're going to build a Tinder competitor, right? We all know how this thing works, right? So Tinder shows you a random profile. You swipe to the right or the left, depending on if you like or dislike the person. So let's give it something cool, like something that I think the tech community would get behind. So we've got Tinder, we've got Grindr. How about like, I don't know, like Docker, for example. So let's call it Docker, all right? I even come with a catchy tagline for it, so that's fantastic. Should container on, all right. So let's say we were making our sample Docker dating app, and we wanted to create, part of this would be I have to show a random profile, right? So we're going to implement that piece of it. So I want to create a method that will return me a new random profile. Now, if they show this thing, my constraints are it can't be the same person, and it can't be someone I've already seen. So you wouldn't want to like vote multiple times on that person. Does this make sense as a setup? Like everyone good? Like shaking heads? Cool. So this is how we're gonna. This is a method we want to test. So let's write an implementation for it. This is again very simple, straightforward code. I have a person. I have this method called getNextPerson. It passes in a user. If we're going to grab a random person, calling this getRandomPerson method, and then this while loop here just says if that person's already in my list of people I've seen, iterate through, keep grabbing random people until I find somebody that I haven't seen, and then return that person. Does this make sense to everybody? Yep. Okay, cool. One thing I would like to note, there's definitely a bug in this that I came up against when I was creating this example. Basically, if you've seen everybody in the database, it will get stuck in an infinite loop. We're going to ignore that for now. I thought about how to change this and make it better and all that stuff, but really it would just make it too complicated. I want to keep a simple example. So let's assume the intern wrote this code. So here's our first problem, right? If I'm going to test this first line, we have a dependency on this getNextRandomPerson. GetRandomPerson, we have no idea how that's implemented. We don't know what it does. We don't know how it's supposed to work. And it's a dependency for us. And a bigger problem is it's a random dependency. So I can write a simple unit test for this, right? Easy enough. Here's my test method. In our setting this thing up, we have a user, has nobody that they've seen. So it's this brand new user to our application. We're expecting them to see a person. We're going to call that person Katie. And then we're going to call our action. So it calls getNextPerson, gets back a result, and then we assert that the person we got back was actually the expected person, Katie. And good news, this works. This totally works. And it's great. I mean, isn't that awesome? It works, except it doesn't work all the time. And that creates a problem for us. So like 60% of the time, it works every time. This is the problem with random dependencies. It's going to grab a random person from the database every single time, and so it's like, well, that's going to cause all kinds of trouble for us. The problem is I don't really know what the value of getRandomPerson is going to be ahead of time. So if there was some way I could force it to be what I want, then that would make testing a lot easier. So what are we going to do? Fuck all the dependencies! Yes! Okay.
I love memes.
I know, I love memes too. So let's talk about actual code and like how to write this stuff. So here's what we've got. You've got this this patch decorator. And what the patch decorator is going to do is you're going to pass it in your module name and then your method that you want to mock. In this case, it's like an unbound method. So you pass it in module.getRandomPerson, right? Then a little further down, you're going to get passed into your method a actual mock object. So this is your mock instance that you can work with. So that's a mock of that method. And then we just set that thing up. We say mock.getRandomPerson.return value is equal to Katie. What's going to happen here is when this method gets called, when getNextPerson gets called, it's going to call the mock instead. And it's going to say, okay, it's just going to return exactly what we want. And that's it. That's all the magic there is to this. So when we get back our expected result, there you go. We have what we want. Does this make sense? Like, this is easy enough to follow? Okay. Good news. It works every single time. It works every single time I run this. It's awesome. No more random dependency. Because I was able to eliminate that randomness out of it and just set a fixed value. So let's take this a couple of different ways. You're like, okay, we can do a whole bunch of variations on this. Let's say I don't have an unbound method, I have a class. So what I've done is I've rewritten this as a class with just a method called getNextPerson and updated the appropriate things. Same general implementation, just kind of slightly structured differently. How would we mock that? Simple. We're going to use this thing called patch.object, and we're going to pass it in the class name and then the method we want to mock. Everything else basically stays the same. Oops. Everything else stays the same in this example. So I don't have to change anything else about it. So this is the difference between unbound methods and classes. Let's take another variation. Let's say like, Dan, you know what? Decorators are really scary. I'm not ready to use that. Let's just do this in a little simpler way. So no decorator. One of the things you can do is you can actually just directly assign this. This is a cool thing in Python where you can just swap out methods if you want. So all we've done here is we've created an instance of application, and then we've just said, okay, getRandomPerson, the method, right, is going to be equal to a mock or a magic mock. Either one works. And then we set the return value like normal. So this is kind of neat. I like this. I find this is sort of like a stylistic difference. Some people like decorators, some people don't. Show of hands, who likes this better? Like, just thoughts. Like, no one? No one likes it better. So we're just going to go back to the decorator then. That's great. Okay. I think it's interesting, like different ways to do this, and in some cases it's more clear to do it this way. Just know this is an option. This is something else you have in your tool bag. One more variation here. Let's say you really love context managers, because I know maybe you like context managers. You can do that. The same thing here too. This is actually really, really useful if you're trying to do something on like the command line. So you just pull open the shell. You're like, I just want to check this one thing. Oh crap! It's calling this other method. You can toss this into a context manager, and this is what the decorator is really just doing in the back. So the decorator is actually just creating a context and putting all your stuff inside of it. Does that make sense to everybody? Cool. So what happens if we call this thing multiple times? We have situations where we have that while loop, right? So we've tested this piece, but what about the stuff in here? What do we do? Well, if I want to test the code inside the while loop, I'm going to run into a problem with my strategy, right? So I'm going to set up exactly the same way, and then I'm going to say randomPerson.return value is equal to, but then I don't know what, because if it gets called multiple times, that method's going to return the same thing, and that person's already me in the list of people I've seen. So it's going to keep churning through. We're going to run into that infinite loop. So that's a problem. So how do we deal with things where we have multiple calls to that mock method, and we want to return different values? So we use this thing called side effect. Same idea here, same decorator, all that stuff, but side effect is slightly different. It takes in an iteratable object. So in this case, I just pass it a list of strings that I want. And then every single time that method gets called, it will just return back the next thing in the iterator. So first it's going to return back Mary, then it's going to return back Sarah, then it's going to return back Katie. So easy enough. First two, go through the list, says, nope, I've seen that, nope, I've seen that. Last one comes through, great, all done. Does this example make sense? Okay, great. Yep, I underlined that, cool. So this is really sort of pretty much it. One quick note about like side effect versus like return value. You might say, well, Dan, why don't you just start with side effects? Like, why don't you just show that? For me, I don't really particularly like the term side effect. I think it's unclear and it's difficult to see. Return value is very specific and everyone understands what that is. And I think the case of using like multiple returns is a little more less likely. So I personally prefer like just using return value. Question?
If you were raising an exception, would you use side effect or return value?
Yes. I'll talk about that later. Yay! Thank you. That actually sets it up really nicely. So let's recap what I learned. So basically, patching mocks brings certainty to our methods. So again, we're eliminating those dependencies. That was the thing we were trying to figure out, right? How do I get rid of that? Even if we have unfinished code. So that developer may have never even written that method. Doesn't matter. We can still test it. That's really awesome. That means you can still get work done. There's lots of ways to do this. As I showed, you pick your favorite. All right? Let's talk about the next one. So the second problem was mocking to verify behavior, right? So let's keep going with our Docker dating app. Let's talk about matching. So you've shown the random profile. And let's say this person has swiped to the right. So your user swipes to the right. When they do, we have a decision tree that happens, right? If the other user has already said that they like them, right? Then we want to send both of them a confirmation email so they can contact one another. If the other person dislikes them, then we sort of want to just let them down gently, be nice, a little, toast that says like, I better luck next time, And if they haven't evaluated them yet, we want to send them a little, we'll do something like, hey, this person hasn't, evaluated you, you're just going to need to wait a couple minutes, okay? So let's write an implementation for that. Again, very simple, so I have a method evaluate, and basically pass in two people, right? If person 1 is in the list of people that person 2 likes, then we're going to send both of them an email. If person 1 is in person 2's dislikes, then we're going to let them down gently, calling this method here. And because whatever that, I'm sure it's a complicated thing, so we'll write that. And if person 1 is not in either, is not in person 2's likes or dislikes, then we're going to give it some time. Okay? You'll notice this method doesn't return anything. So like, how the heck do I test this? Like, there are no return values. I have no idea what to do with this. I can't evaluate that. So let's focus on a very specific piece. Let's say we're going to, for the sake of a demo, let's say we're going to evaluate this middle one right here. If the person dislikes, the user, how would we test that? So we're going to use our good old friend, the patch, right? We're going to mock that method. And I just got a simple setup here. Person 1 is Bill. Person 2 is just going to be a dictionary with an array of who they like and dislike. Just some implementation for this. Pass these things in to evaluate. The important piece is down here at the bottom. So we're going to use this thing called call count. And it does pretty much what you'd expect. It tells you how many times that method was called, that mock method. So when evaluate gets called, it goes through its decision logic, does its thing, and then it lets you know how many times it was called. That's it. It allows me to verify that the correct thing is being called. Great. Now, you might say, well, okay, the call count's great, but what if you wanted to check like the parameters being passed in? Like that would be more thorough, right? Probably a smarter thing to do. So let's do that. So we have our same exact setup. The only difference here is this bottom line here, where we're going to call a different method called assert called once with. That's a mouthful. It combines those two things. It says, okay, is the call count exactly 1? And was it called with this parameter? So in this case, I'm going to pass it person 1. It should match. This is really, really valuable and important. And actually, I think this is a good practice for everyone because obviously you saw when I was explaining it, person 1 and person 2, that could really easily get flipped. And it would be really, really trivial for somebody to accidentally put the wrong thing in. And now you've got all kinds of problems going on. So that's an easy, simple thing we can use to test and have better quality code. What about the other methods? So we verify the thing that should be called gets called, but we also want to make sure the thing that shouldn't get called doesn't get called. So these methods here, right? I don't want an email to go out. I don't want other things happening. So it would be good practice for us to also verify those. But in order to do that, we'd have to be able to mock multiple things, right? So I need to be able to have more than one mock in my test method. The good news is you can do that because in Python, decorators stack, and that's okay. You're allowed to do that. And because they're just nested contexts, that's also okay. So that's pretty cool. It's really nifty. One thing I do want to point out is because these things are being applied, they don't get applied top down, they get applied bottom up. That's just like how decorators work. So these are not keyword arguments, these are just ordered parameters. So you have to make sure you have the right order for your mocks, otherwise you'll be testing the wrong things. That's a little bit tricky sometimes. Essentially though, the implementation is the same basic stuff, and then down here I just say, hey, make sure the call count for those things is 0. Does that make sense to everybody? Cool. Let's say you're like, Dan, decorators are scary and I don't particularly like that, or I don't like the possibility that I could screw that up. They also provide this thing called patched.multiple, which gives you a slightly different implementation of this. You pass it in the class and then the methods that you want to mock, and then it will provide those as keyword arguments to your method. So this is nice because you can't really screw that up. It'll tell you if you put the wrong thing there, and the downside is you can't name them mock whatever. And sometimes that can be a little confusing, but more or less the implementation is the same. Okay? So 2 different ways of having multiple decorators, up to you, your personal preference. So let's say we wanted to test multiple calls. So we've covered this thing, that's good, but what about when I call the same method multiple times? I want to make sure that I'm passing the correct parameters into the method, right? I want to make sure I don't, again, fat finger it and send, copy paste the error, like send email to person 1 twice, So we're going to focus on that little section. So, multiple calls looks like this. Down here I have, let's see, boop, this little section here, call args. Call args list. What it will do is, again, you call your mock, and call args list, all it says is, I'm going to provide back an array of all the things that got called. And it's just a little abstraction for, it was called, and then here's the parameters that it was called with. So I can take that out and say, okay, my first call and my second call, and then I can verify first call and second call were called with person 1 and person 2 respectively. Does that make sense? Cool.
That
question?
The call object.
Yes. Oh, so the call object is specific to mock. So it's just like a little abstraction. It was weird because I was expecting a method signature or something like that, something else like a function, but really it's just a wrapper around it that says like, okay, it was called, and then here's the parameters it was called with. Nothing more, but it's just part of mock's library. Excellent point, thank you. Okay, almost done. I know I've been saying the word test an awful lot, so there will be very soon. Think about the kittens, or I guess, okay, wait, no. I know some of you guys are not kitten people, you're dog people, so think about the dogs,
Pandering.
I know, I'm pandering. All right, so let us brace ourselves for the next subject. So what was the third thing that we were going to test? Error handling. Also, I want to toss in built-ins because that's kind of neat too. All right, let's do this. So, we're done with the Docker dating app. Let's just do something easy and simple for everyone. Let's say I have a simple JSON reader. This is just a little, all it does is it's going to take a file, it's going to open the file, and then parse it as JSON, return it back as a Python object. This is very straightforward and simple code. And suppose you wanted to put a little wraparound in case, for whatever reason, it breaks, it throws an IO error or a value error, like it's not properly formed JSON. We just want it to return an empty string. Something like that. That's our test setup for a simple JSON reader. But I want to test something like this. This is a little more scary, right? You've got a built-in method there, open, and you've got lots and lots of stuff packaged together. So for me, it seems like I want to break this down into 3 things we have to test, right? We want to test that we parse a valid file, right? So I'm going to pass this thing in, and it's going to return back valid JSON, okay? We're going to test the IO error because we want to test error handling in that situation, and we want to test the value error. Make sense to everybody? This is a good plan of attack. Okay? So, how do I test open? Well, let's just create a sample file, right? Everybody, that's the right way to do this, right? No, no, no. You know better than that. You know about mocks. We don't need to do that. That's crazy. So, can you actually mock a built-in? Yes, you can. You can totally do that. It's, again, one of the wonderful things about Python is all that stuff is up for grabs. So we just do _built-in.open. You can mock that. And then you say, okay, you've got your mock open, and they say return value is this, and that's, it's done. Hooray, everything's simple. Except it's not. Sorry. I wish it were quite that easy. Slightly different. So when I was going with this example, it got a little bit complicated, right? So OpenReturn is a file object, right? And then we have to call this, open file name .read. So really .read is what I want to mock. I want that to be the thing that returns back a string of JSON that I'm going to try and parse. So what we really need to do is mock file.read. But there's a problem. It's an instance, not an actual class that we control. So I can't just hotspot this thing out. So how do we do that? That's crazy, You told me that mocking would solve everything. Well, have you tried solving with mocks? Because that's a good way to solve that problem, right? Yeah, okay, cool. So here's what we're going to do. We're going to keep our same structure. We are just mocking, open. And then we're going to add 2 more lines, right? Here we say, okay, its return value is going to be another mock. And then this mock that we create here So we just use that same, that alternative way of creating a mock, and we just say, okay, return. Oops, sorry. And we say, yeah, the return value of that is going to actually be the JSON. So let me take this let me take you guys through this again. Mock.open.return value is going to return back a mock that we created. That mock is then going to return a value that we want, which is the string of JSON we will parse. Does that make sense to everybody? Cool. So this is neat. Like, you have control over these things. You don't have to be powerless, against just things that don't work out. It's very, very flexible. Okay, so what about error handling? You promised me that we would talk about error handling, and it's actually really simple. We just use side effect. Ta-da! Like one line of code. You mock open, and you say when you call mock.open, or when you call open, it's going to throw an IO exception. And that's great. It allows us to handle everything else exactly the same way you want to. So you've seen this general setup. Same general idea there. What about something a little more complicated? We want to do the value error, right? In our code. Slightly more complicated, right? We're doing JSON.loads, but same general idea. Side effect. So we have our mock, and then we say, when somebody calls loads on this, it's going to throw a value error. So it gets all your stuff back, it returns it, throws your value error, and now you can test it. Does that make sense to everybody? I know this one's a little more complex. Cool. Yes?
Maybe it's a silly thing. Why could we also just put in some bad JSON?
So the problem you're going to run into if you just say, like, I'll just put in some, you could put in some gnarly JSON. But I find that this is more explicit. It's like, I want to throw a value error. If I were another developer looking at this code and it's just like, okay, that looks like some mangled JSON or whatever, I might misinterpret that. This is really clear. It is going to throw a value error. There's no question about that. Like, that's what it's going to do. If I give it some mangled JSON, maybe it's a little open for interpretation. But I mean, it's not the end of the world.
The thing I would contribute also is that JSON, that might be a bit of an edge case because you can put the whole thing in one line.
Yeah.
Where I've used this a ton for things like, we have code that uses pill to open an image, and I don't want to truck open various forms of corrupt images floating around my test suite.
Yes, exactly. Or, that's the other thing. We don't want to have to just have these random test files committed to our repositories. Like, what is this? Oh, all these test files are for these random obscure things. Then you have to maintain them. This is all inside the test. If somebody wants to maintain it, there you go. It's all there. It's all on GitHub. I can point at it. I can touch it. That's a benefit to us, and that improves clarity. Yes, thank you. Cool. So that's pretty much it. Let me wrap up. Let me give you guys some takeaways for this. Okay. If you remember nothing from tonight, mocking makes writing unit tests a lot simpler. All the examples that I showed were simple because we're using mocks, right? Because we're putting this stuff together, it's like, I don't have to write a bunch of extra logic, or I don't have to handle a bunch of special things. Just mock it, and then I can test the thing that I want to test. It helps us to eliminate dependencies, it helps us to verify behavior, and it helps us to handle errors. I think for a lot of us, this just requires a little bit of practice. Seeing it in the presentation, it's like, okay, that kind of makes sense. But I really do encourage everyone to kind of go home, just try it. It's surprisingly straightforward to pick up. And once you start using it, it's like, oh yeah, this makes sense. Like, okay, I get it. Now I understand why it's useful and when to use it. Okay? And if you want to try it on your own, there's the link to the documentation. If you're not running Python 3, you can just do pip install mock. Very, very straightforward. And what I did was I just created a sample class and started poking at it. What are some situations that would come up? What are some things that this would be useful for? That's how I learned this, and I encourage you guys to as well. All right? Let's go write some tests. Yes! You guys excited? Okay. Questions? Yes?
So I'm new to testing, so that might factor into this question. But so you mocked out the intern's work in the beginning, the get random, that method. When he finishes the work, your test is always going to pass because you're mocking the return value, right?
Correct, but I'm not testing his code.
Right. So would you need to write, or would you, in your experience, write another test that actually tests his code? Because how do you then have a test that his code actually works as it should when the app is fired up? See what I'm saying?
Yeah. So we would call this isolation. So we're going to have a set of tests for the get random person method, And then we're also going to have, you know, a set of tests for get next random person. In like testing terms, we call this like the class under test or the method under test. So in this case, like my example, I'm testing get next person, and I want to stay laser focused on that. I don't care what anybody else is writing. I just care about that method. When I go to test get random person, I'll like write a whole suite of tests specifically for that.
Sure.
Does that answer the question?
Yeah, it does.
Cool.
Yeah.
In the back.
What is magic mock compared to mock?
So as far as I understand it, like magic mock and mock are like they're part of the same thing, and there's some distinction between them that of like when you want to use one or the other. But I'm really uncertain as to what. Yes.
Magic mock, everything that you ever do with it will just give you another magic mock instance.
Okay.
So like if you did that magic mock on open and you called read, you get back a magic mock. That's great. The problem is if you called, you know, read and you mistype the name, it will also return magic mock.
Right.
So it works great for things that like, okay, I want to test this Twitter API client. I don't want to have, you know, keys and things like that floating around. But you really have to make sure that you use you know what you're testing, and you only test that, and you still have like some sort of like an integration test later that there, because I've used it a few times, and it's very easy to end up with like, well, that was almost but not quite what the real code does, so this whole test was a waste.
Mm-hmm.
It also lets you mock double underscore methods on the object.
Oh yeah.
Which you can't do on a normal mock.
Makes sense to me. So there you have it. You know. Yeah. Other questions? Cool. Oh, yes.
So I'm actually brand new to Django. I mean, how would you mock
Oh,
the framework? Or
sure. So I thought about really hard about putting in like lots of Django examples, but I thought this might be a little overwhelming. You know, especially if like this is your first time doing like mocking or unit testing of any kind. So essentially, it works the same way. One of the nice things is that mocks allow us to do like chaining of methods. So you have your call to like objects.all, you know, and you can just say, okay, this is a mock. And that's it. So I want to grab something from the database, you just say like, okay, that's a mock. You know, and then when it tries to grab something, I just say, you know, object.all.filter. Whatever, return value is this. And then when that particular thing gets called, you will get back your thing. This is really useful for like, I'm testing a view and it's supposed to get back certain data, or I'm testing the view and I want to like mock the request. You know, so the request has a whole bunch of extra stuff on it, and I want it to have these things. Does that make sense?
Yeah.
Anything else? Yes?
It's more of like a philosophical question, but do you mock your interactions with the database? Do you mock the ORM when you're doing your unit tests?
I would put the preference on doing that, only because I really dislike having to load fixtures. My problem with fixtures is that you spin up the test database, but then you do your, like, and you have your fixtures, and that's one more thing you have to kind of maintain, and then you say, well, if I migrate my data, then I also have to update all my fixtures. And it's not really an easy consumable format that you can change. For something simple, the little tiny fixture, like, or if you have a really, really big, like, this is a huge set of data and it's a very specific thing, maybe fine, so be it. But I would say we should definitely try our best not to, you know, hit the database. That's really an integration test, and our stuff will be faster. So that's a big benefit to us. Anything else? Great. Thank you guys very much for coming out. Let's get some beer.